These sessions are every 2 weeks and mostly talk about tech, what we've learned, and then what we can share. It's usually about 2 hours, Saturday mornings here on our Minnesota time. And today, Ben is going to talk part 3 of AI, no, sorry, not AI, API development using Go with some sprinkle of LLMs in it. So this is kind of like his part 3 or third session, I would say. But before we get started, I have a few tools that I've kind of, wanted to share with you. Let me share my wider screen here. Okay, can you see my screen? Maybe not. Yeah. Can you see the notebook LM screen?
Yeah.
Okay. So I know I've talked about notebook LM before, but it actually has a new feature that I wanted to kind of showcase. Maybe for those who don't know what notebook LM is, it's a tool that is created by Google. Essentially, what it does is it uses the concept of RAG, where you basically have sources as your own document. So you upload your own sources. So whether it's PDF, websites, you name it, and then based on those sources, you can ask it questions, for example, right? Like, so for me, what I usually use it for is to create, job descriptions. I would go and find job descriptions from other companies that I like, and I would put them as sources, like 5 sources, for example. And then I'll say, hey, based on these job description, create a new one using those ones, and then it'll create one for me. But the new feature that is available now is the availability of let me see if I can find one here. It allows you now to before, let's say you create a new document or a new overview or new something based on these sources. Before you were able to create an audio overview or a conversation based on that document. So you have like 2 AI basically talking to each other about that document. Now the new feature is that you can now interrupt the AI. Basically, as the 2 AI are talking, you can actually interrupt them and then ask them questions. So like it's almost like having a conversation with friends in a way, and then you can ask the questions. So, I've seen people use it for studying. Obviously, it says your study guide. So I think that's kind of like the new feature that I wanted to share with you, because I've talked about Notebook LM a few times already. The next tool is called Mind Studio. So I'm still kind of like trying to get familiar with it, but I thought I would share it still. It's basically a platform that helps you build, as I said, like AI applications. So for those who have done, I would say, data engineering, and then maybe I've used orchestration platform like Airflow, for example, where you can kind of like build like a pipeline, and then create a pipeline, and then kind of like or a workflow, I would say. This is similar to that, where you can build workflows or pipelines of steps, and then and they claim as being like low code, right, or no code almost, and building AI applications like that. The way they look at it is that you're able to build let's say like a sales pipeline or a sales collateral. But for those who have been here before, I've actually done a presentation on something similar without actually using like a UI or anything like that. Like, I don't know, for those who remember, I built that agent using through AI, and I didn't have any sort of like nice UI behind it or anything. So I feel like this is kind of like a UI version of like a true AI, for example, if that makes sense, for those who know what true AI is. So I'll still give it a try, and then perhaps in a few weeks or so I can talk more about it. But I wanted to share that with you so you can see what it's about. Yeah, as you can see, you're able to create like these pipelines, right? So it reminds me a lot from Airflow, for those who know what Airflow is. And the last one is actually Gemini. So I'm pretty sure when these like ChatGPT came out a couple of years now, for those who remember, Gemini also kind of like came up and it was not great at all. Like for those who've tried it, then it was not great. It was not giving you the right answer. You name it. Right? 2 years down the road, and Gemini 1.5 or 2.0 came up. I think this one came up like maybe 3 weeks ago, and it's actually pretty good. Like it's really fast. Like I think the name Flash actually I think comes from the speed. It's really fast. Like when you ask a question, by the time you hit enter, it's already started to answer. So I've actually started using it a little bit more. Because now I'm paying the $20 version of like ChatGPT, right? So if I can eventually like stop using ChatGPT and get this for free, I'll do it, you know. So I mean, we can give it a question, for example, like, and you can see it's like already answering like what's quantum physics, and it gives you a really quick answer, like really quickly. Right? Honestly, I've noticed that ChatGPT has gotten a little slower. I don't know if it's because of the demand on their servers like recently, but it has gotten surprisingly slower in the last couple of weeks and months. So I've been using Gemini a little bit more, mostly just for speed, and and it's free, right? They do have like a upgraded version that kind of like gives you a little bit more feature. So for example, 1 million token context window, which is a lot. And then it's integrated with like Google Docs, and you get 2 terabytes of storage. So, I mean, it's still $20 a month, similar to ChatGPT. But I guess the beauty of this is that if you're using Google, then you get 2 terabytes of storage. So you get a little bit more, I guess. Yeah.
How much did they pay you for that?
They didn't pay me anything. I knew you were gonna say that. I know it sounds like I'm preaching for Google or Gemini, but no, I'm not. I'm just kind of giving you choices, So yeah, I wish they paid, but nope, they did not pay me anything for this. Any questions or comments? Have you tried any of these before? Whether it's Notebook, Gemini, Mind Studio, any of these?
I've definitely tried Gemini actually yesterday, and they're getting better. They still have like some accuracy issues, but it's much better than they started.
Yep, like 2 years ago, like it's way better than 2 years ago. That's for sure. Yeah. Like, I remember when I used it, it was frustrating because it would not answer you, or it would just not give you the right answer, things like that, right? So Google is definitely trying to catch up to come back. So that's really it, guys. I don't know, Ben, if you're ready to go, but that was kind of what I wanted to share with you this morning. Yeah. And for those who just joined us, thank you again for coming. Yeah.
Yep, I'm ready. Let me share the screen. 1 second. Let's just share button. Okay, so good morning, everybody. Can everyone see my screen okay?
It's a little small. I want to increase the air though.
How about now?
It's good.
It's good?
For everyone, is it good? I mean, for me, it's good, but I don't know if about the audience.
Looks fine for me.
Yeah.
Okay. So it looks like we have quite a few new people today. And so I actually have a question. How many people were able to attend the last two sessions in this group today? I just want to have an idea of how far I should go back to, to add more context so that you're not lost for the new ones. So let me see.
I would say just add a little bit of context because I think about half were not part of part 1 and part 2.
Okay. Okay, so let's go back to the beginning then. So what I'll do in the interest of time is that I'm not gonna dig in too much details for the demos of the first two sessions, and I'll spend more time in the demos for the last session, if that's okay with everyone.
Yes,
So,
Ben.
yes.
Could you also provide a context on of the overall picture for those who have not attempted before?
Yes. So let me see. How do I start this? Okay. So the main idea that we have been discussing for the last two sessions. Let me see if I can. That's a good example. Okay. Let's take Fast API. So when with the current trends of all of the LLMs and building apps with Python and so on and so on, this is one of the go-to tools in order to create an API. And the reason why this is a go-to tool is because when it comes to building APIs, it combines a lot of concerns and leaves the developer with just defining some entities for the API, as well, and doing some sort of validation, right? So by just writing a little bit of Python, let me see if I see an example. By just writing a little bit of Python, the developer quickly ends up with a fully defined contract in the form of OpenAPI. You can see the link here, OpenAPI.json. And then another concern that another feature that these types of tools have is that they also quickly provide like a Swagger UI, so that we can inspect the details of the contract in terms of the paths to use, as well as the entities to send in or receive, right? So basically, in one go, the developer writes some Python code and ends up with a contract that the consumers of its API can use. So the issue with that I was trying to describe in the first session is that it's fine. This workflow is fine for smaller teams. Maybe a couple of developers or a 5-person team. Because the fact that all of those things are derived directly from code makes it so that the contract that we see here will always be changing as part of the development process. So for a small team, the churn that it's going to create, can be, can be bypassed quickly because it's a small team and the communication is quite efficient. But on a larger scale, for teams of, 10 people or more, or even teams collaborating together, or companies collaborating together for an API, this is not acceptable, because the burden of the communication of what we're all supposed to do what, and what the entity should be and all that, it will quickly become problematic. So for that reason, as part of this presentation, I was trying to show a different approach, which is the approach of coming up with the contract first. Okay, so in this picture, the actual contract is linked by the OpenAPI JSON. So we can try to see what it looks like. Let me see if I find an example. So I'll give you one. Pet clinic. Okay, so this is an example that's really available on the internet. Let me share the link. Okay, so let's take a look at that JSON. Okay, so here for the contracts, there's the two most common formats are Swagger and OpenAPI. And in addition to that, the Swagger UI can display both. So let's look at this. So you can see right away that this contract is quite long, right? And the fact that it's JSON, and the fact that it's in JSON format, and that it contains so many details, it's very much error prone. If anyone has to write such a contract first, so instead of writing code that generates the contract, instead, if we do the contract first and one person is in charge of writing this by hand, it's mostly not going to be correct, right away. It will take a few iterations to write a completely valid contract, and then in addition to that, the teams involved or the people involved in either consuming that contract when it's deployed or implementing the contract will have a few discussions, about adjustments to make, like maybe not, let's not use this path, let's use this other path, or this entity should have fields A, B, C, D, like I add another field called Z, and so on and so on, right? So because this is tedious to write by hand, one thing that I've proposed is to revert to a new tool called Q. So Q is both a specification language and at the same time a tool to work with both YAML, JSON, and protocol buffers. So the main advantage of Q is that, let's see if I find an example. Or actually, I can look at my notes here. So let me skip off and let's go down. Okay, so the main advantage of Q is that instead of writing that giant JSON by hand, we can specify like entities, like in this example, using a very terse syntax, and still end up with a valid JSON that will look a bit like this, right? So instead of writing all of those, this giant file by hand and possibly making some errors, it's possible to write few lines that pack a lot of details like validations, field names, and so on and so on, and then turn that into this big JSON here. So for the new ones, I can actually show you some of the steps here. Let me see. Forward. Let's see, move 5. Okay, so in this example, so you can see in this example, I'm defining some entities using Q. So the file will be image2.q. So it's this file over here, right? And you can see that what I'm defining here as contract, I'm defining an entity called image upload. And this entity has 4 fields, an ID, which should not be longer than 36 characters, and that should also be alphanumeric. Okay. The second field should be at least 3 characters and no more than 100, and alphanumeric. And then I have another field called stream, which is a Boolean. And then I have a blob here. I'll come back to what the blob is, but you can think of it as a string for now, which should be at least 3 characters and go up to 13,900,000 characters. Okay. Plus, it should also match this regular expression. Okay, so this string should be prefixed by data : image / JPEG or PNG or GIF or WebP, and then semicolon is 64, and then alphanumeric. Okay, and then I have a second entity which is simple. It's an image info that contains a field which is a string. Any question on that, on this definition?
Yes. So I'm trying to understand the logic here. So let's take the prompt one, for example.
Okay.
So we have string and the equal sign and then the whatever you call it. So that part right there, can you explain that? Because so I'm trying to understand which ones are the blocks.
Okay, so the name of the field comes first, and then the name of the field ends with the colon, and then space. After that, we have the type of the field. In this case, it's a string, right? And then in the Q syntax, we can append some additional requirements for that field. So the first requirement is this one, that it should be at least 3 characters and up to 100. Okay, so this one is the requirement for the length of that field. And then another requirement is that it should be alphanumeric. And also it may contain some underscores and that.
Got it.
So the syntax for Q is very terse. So you can pack a lot of information, like I was saying, and the delimiters between the different requirements is the ampersand sign. Right. It's also well documented. Let me share the link for the new ones. I'll share the link here in the chat. Any other question on that? So the nice thing is that yeah, go ahead if you have a question.
Hi, yes, I was going to ask, is this regex, these limitations that you're putting in there?
Yes, this part is, you can think of it as a regex, but this is valid syntax for Q.
Okay, so we have to know that syntax for us to put these limitations.
Yeah, but it's pretty straightforward actually. If it's your first time,
Yes.
seeing queue, I recommend doing some reading on the queue website, right?
Will do. Okay.
Yeah, and also, I mean, if you want to make use of it right away, even if you don't read the whole thing, you can at least read why they created queue in the first place to get a better sense of it. And then if you really need to generate some queue syntax, you can just use ChatGPT or something. You know, it's a tool. It's not hidden, but not many people know about it. So some places where you might find the use of queue, I think it's in Kubernetes, the Kubernetes source code, if I'm not mistaken. Let me double check. So Kubernetes. Okay, let's search for queue. Oh, maybe I'm not saying. So,
Yeah, Ben, I was just asking that the syntax seemed a little bit. I wanted to know if it was regex or not. So yeah, just go ahead. Sorry to interrupt.
yeah, so okay, so the main purpose of queue is to simplify the different workflows that we usually have with configuration data. Right. So nowadays, when we work on cloud native applications, the configuration comes in either JSON or YAML, right? And those things are not codes; they are just static text. So whenever we make a mistake, those mistakes are very hard to catch. Okay. So since it's very hard to catch, it makes more sense to use actual code, to generate those things like YAML and JSON. But at the same time, if we have actual code that looks like Go or JavaScript or whichever other language, those languages are at the same time too powerful. So we might end up making the configuration more complicated. So Q was designed to be kind of like in the middle. It's code, but it's at the same time almost like configuration, and then the Q compiler takes care of validating what we wrote. And then also it has some facilities to generate the corresponding YAML or the corresponding JSON. So it lives in the middle. Okay. And Q itself is written in Go. And because it's written in Go, it has some of the same facilities as Go, in the sense that we can also import some packages. We can directly integrate it in a Go code base and so on and so on. So actually, I can show you that. So this is the same entity that I was just showing you. And in here, what do you see? You can see that I'm using the QCLI to turn my image2.q into the corresponding YAML, but not just YAML, but YAML in the style of OpenAPI, and then I end up with this. Okay, so you can even see this. The title says generated by Q. So notice all the things that you not have to write. The same entities for upload and image upload and image info. You can find them here, right? So if you make the comparison between writing all of this by hand versus writing this,
Yes.
right? It's a big difference. That number. I forgot what my number is. I forgot what my numbers don't show up for some reason. Maybe it's because I zoomed in. But basically, I mean, I don't know how many lines is this, but you can see that, actually, let me open this side by side. Okay, so my numbers don't show up. I'm not going to worry about it, but if you just visually compare the components block, from the start to finish, and then compare it to what's on the right side, you can see that it's a significant difference, in terms of line of code and details, right? So
yeah, absolutely. So the indentations also are usually a nightmare, and those dash when you.
Exactly. In YAML, if you make an indentation error, it's not necessarily going to blow up. You're only finding out after the fact when you, let's say, if it's your Kubernetes configuration, when you apply YAML, that's when you realize that, oh, there is a mistake or there's something wrong, right? So this one helps shorten that path, by catching the error right away. So, okay. So when we turn this queue file into the corresponding YAML in the style of OpenAPI, one thing it doesn't do is that it doesn't take care of the paths. Okay, you can even search the queue documentation if you want. You're not going to find it. They explicitly do not support this for now. Okay, which makes sense because there are so many concerns in the definition of the actual endpoints that it's better to leave the developer to account for it based on the business rules and requirements. Okay, so since it doesn't account for the paths, what we have to do is to manually include the paths definition. So like I've done here. So in this case, I'm adding this path, extract image info, and then I have a little bit of a description. And then I can still refer to the same entities in the components block. So I basically copied what was generated from Q and then changed the paths into this. Okay. So here I'm defining these endpoints, and it's a post. It accepts post requests, and then the body is in the shape of the image upload, which is defined in the components block. So just like on the right side. And then the responses, when they are successful, it's a 200. And the answer, the shape of the response is image with the fields, image info with the field info. Okay. And then I'm only defining the 400s for invalid payloads. Right? I could have defined some additional HTTP codes, but for the sake of the demo, these two will suffice. So this one, since we are validating since we have the contract on the right, the expectation is that if the payload does not fulfill the contract, then we will have some sort of 400 error in return. Any question on that? On the notes? Okay, so let's continue. So once we have that YAML file, so again, the goal is to end up with a fully defined contract in JSON format. Okay, so now that we have the YAML, we have to convert it to JSON. So this is what's being done here. I'll show you quickly the CLI.go. I wrote a bit of utility to help do that. Okay, so it's going to turn that YAML file into JSON. And then, yeah, so at that point, then we we have the fully defined contract. So I can quickly show you. So this is what it looks like. Okay, so you can recognize the same entities and then the same paths that were defined with the 200 and 400 responses, you know, and then the components block with image info and image upload. Right?
Quick question.
Yes, go ahead.
So how did you do the paths if it doesn't include them automatically? How did you define those paths? Did you use an old template?
No, I just wrote them by hand.
Okay.
I just wrote them by hand. That's what I was showing here. So with Q, I can get up to this state over here, minus the paths. And then, so what I had to do is to copy this into another file, which is called demo5.yaml. And then in that demo5.yaml, I added this block manually.
Okay.
Yeah. Okay. So you see that very quickly, starting with a Q file, we end up with a full-fledged OpenAPI specification, OpenAPI contract. Okay, so I can show you what it looks like if I reload this. So this is the contract. Okay, so you can see the endpoint, it's a post request. This is the image upload shape. You know, the schema is image upload. We can see the same fields that were defined. And for the responses, this is an example. And then it fulfills the schema. Okay. Then you can see the same thing again at the bottom. Okay.
So question.
Yes, go ahead.
More of an historical question. Why didn't like tools like Fast API and all that stuff decide to go with Q rather than YAML?
Well, I mean, for the Fast API, all of this workflow I just showed, it's automatic. It happens automatically.
Yeah, I'm talking about, let's say, OpenAPI, right?
Mm-hmm.
Why isn't Q, like the Q language, their preferred language? Why are they going with YAML files?
Oh, okay, I understand. Q is actually quite new. I think it was first created, I think, maybe in the last 5 years, I want to say. Whereas the OpenAPI and Swagger and all that, like those specifications, they are way older. And at the same time, most programming languages in use out there have support for at least JSON, right? Whereas Q is new and it's fully integrated into Go, you know, but and not much else.
Gotcha.
So,
Thank you.
yeah, so it was created later and then it's only integrating in Go as of now. I mean, there will be support for additional runtimes like later on, but for now it's mostly a Go tool. It doesn't mean that this workflow that I just showed cannot be used for other stacks, right? Q will take care of defining the contracts, generating the YAML and the JSONs and all that, you know, and then once those contracts are created, the actual implementation of the server can be in any languages out there, whether it's Node.js, Python, like it doesn't matter. Okay. So, okay, so let's go back to the notes. We'll go back up. Okay, so when okay, so coming back to the discussion, when larger teams collaborate, it makes sense to come up with the contract first, right? So that everyone will get a chance to review the contract, make modifications and all that. And once the contract is complete, it can be published somewhere with the company data, whether it's the Jira website or it will be published somewhere that everyone can access. And then teams can simply go their own way and work on the implementation or work on the consumption of those contracts. So one team will be in charge of developing the backend that will fulfill that server-side contract. And then another team will be in charge of writing a client to consume that contract, right? And there won't be any misunderstanding of what's supposed to be or what is supposed to happen during the exchange. Okay, that way everything is made upfront, and then teams can focus on actual work versus having to experience that constant change, that constant churn that happens every time the code change, like in the fast API example. Okay, so the next step after the contract is that it's one thing to define a contract, it's another thing to fulfill the contract or to enforce it. Right? I think in the last session I gave the example of people driving in the city. There are laws and regulations for the roads and cars and how people drive, right? So, for example, why do people actually stop at the red light? They can easily come up with a reason why they need to run the red light. Like maybe they have to be somewhere and they are very much in a hurry, but they still stop regardless. The reason for it is because you have law enforcement who makes sure that the contracts of the specified contract that stipulates that people should stop at the red light, the law enforcement makes sure that this is respected, right? And because people do not want to be punished, by receiving a traffic ticket or anything like that, they stop. So in the same manner, when we have the contract, when it comes to the APIs, we also need to enforce the contract. So the way to enforce the contract is that once the contract has been established, the runtime of the code should take that contract into account and validate the different exchanges, right? So when I say the different exchanges, there are two. When the client makes an HTTP request to the server, the payload needs to be validated against the contract. And then at the same time, when the server responds to the client, the response has to be validated also against the contract. This is to make sure that on either side, the contract has been respected and the data is valid. But in reality, most implementations will just take care of validating the client's request. And then on the response, it depends. Some implementation or some companies will just dismiss it and respond with whatever data they respond with. Some others will take care of validating those responses as well. Okay. And when it comes to Q and Go, I mentioned that Q is not only is written in Go, but has a very tight integration with the Go runtime. And because Q is written in Go, it's just another Go library, right? So we can import Q and copy over like the entities defined in Q, and we can use them to validate a payload. So this is a trivial example here that just takes in some data and validates it against a schema. I mean, a schema like which is a string containing some Q syntax. Right. Any question on that? No questions? Okay. So let's continue. Let's go to demo 4. Oops. Oh, okay. So, okay, so demo 4. Okay, so in the, so I mentioned earlier something about coming back to the blob. So in demo 4 that I covered last time, the blob field is meant for some image data, because here the entity is called image upload, right? So when we are uploading the image, it means that the content of that image has to be part of the payload, and that image payload is represented here by the blob. Right? So since that image payload is represented by the blob, that image has to meet some requirements. Okay. So this weird number here, which is 13,900,000, blah, blah, blah. When you do the calculation, it comes down to an image which is around 10 megabytes. Okay. So, actually, I forgot to share the link with you. Sorry. Let me. I put the link in the chat. So again, don't just take my words for it, especially the new ones today. You can do some reading and check my calculations here. Okay. So with this in mind, what does it mean? It means that my expectation is that when the clients upload an image, they should not upload an image which is larger than 10 megabytes. And not only that, you can see the regex that defines the image, right? So an image on disk is just a file, right? And that file contains some bytes. And the process of uploading those bytes to a remote server, we need to find a good way to serialize those images, in order to upload them. So the process that I've used here, and even last time in the demos, is that I'm grabbing the bytes, I'm reading the bytes out of the actual image, and then encode those bytes into base 64. Okay. And the image from which we grab the bytes, can be either a JPEG or a PNG or GIF or WebP. Okay. So see here, go to Scratch. So it means that, let me copy this one. So it means that the actual image will be something like this. And some base 64 string like this. Right? And when my server receives this, oh, sorry, this part is, yeah, this one is there. So when the server receives this, the server will inspect the prefix of the string, and it will see that this blob is basically an image with MIME type WebP, and that is encoded in base 64. And then the actual blob, the base 64 encoded bytes are following the comma, right? That way, using that metadata at the beginning, the server will be able to decode the image and get the actual bytes, and then it will be able to process it. Does it make sense?
Yes.
Okay. So let's go back here. Okay. So this is the previous demo. So we saw this part already. I mean, something similar, and I also showed you how to generate the contract. Now we can inspect the code. So let me see. Okay, so the first thing, one reason why people quickly run to tools such as FastAPI and many others that do similar things is because they think, oh, this thing has a nice UI, right? Then you define and you create your API, like right away you have a nice UI, and then if your preferred language or stack doesn't do that, then you feel a bit jealous, right? Well, it's actually nothing. This thing here is the HTML for the UI. So this UI that I showed you, we do view source, it's the same thing. That's all it is. Okay. Let me zoom a little bit. See, that's all it is. So it's a plain HTML file that points to some remote CSS that everyone can use, as well as some remote JavaScript. The only trick is that when the page loads, it's gonna try to retrieve the JSON file. And as long as it's a valid OpenAPI spec, it's going to render this page. Okay. So if I go to network and reload this, what did I do? Let's say reload. Okay, so if I reload this, what do you see? You're gonna see calls to retrieve the CSS and the JavaScript. So same thing here, these two. And then this is the call to retrieve the OpenAPI spec. You know, so that call over here. Okay, so that's all it is. So since it's that easy, we don't have to feel jealous about FastAPI or any of these other tools. We can just copy that string into the code, and then we can just serve it. Where is it? So see the get/docs. You know, we just render that. We just render that template, which is defined here. Okay. So, so in addition to that, we need to render the OpenAPI in JSON. So this OpenAPI JSON is read from disk, and the way that it's done I'm just using the Go standard library for this. It has the this annotation, right? This one points to the current folder that contains the OpenAPI JSON. And so we place that current folder into the content variable. And let's see. And we just, basically that content becomes like a virtual file system. And we can just read the JSON out of that and serve it. Okay, so this is what serves that JSON over here. Okay, and that's pretty much it. For the actual endpoint implementation, which is this one, we can navigate to okay, so this is the actual implementation here. So like I was showing you in that small example, we can just copy over the queue definition, and then out of that we can derive a schema, and then out of that schema we can build our validators. So for the upload, we just specify the path in that queue definition, which is pound image upload, which will be this one, or pound image upload status. Okay, so whenever we make the call, we can read the body and decode it into an image upload struct. So the structs are defined here. They match the definitions in the queue, right? So we just call validate image upload or validate image upload status. And if there's anything wrong with the payloads, then an error will be returned, and then we can handle it. Does it make sense? Any questions?
Can you go over that part one more time again, please?
Okay, so let me open the. So let's open the demo 5. Okay, so let's look at this one. We define the structs to match what's inside the queue definition. So we have ID prompt string blob, ID prompt string blob, then info. Okay. So once we have this, we can derive the queue schema out of that string. So that string is called schema, right? So we can compile it, and we end up with a queue schema in memory. And that schema can be used to create a validator. So if we want to validate the image upload, we just create a function that accepts this image upload struct, and then let me see, and then we can use the schema to look up the image upload queue definition. So it's going to look up this part over here, and once it does look it up, it's also going to understand what are the requirements on the different fields, right? And the image itself, in order to be validated, can be encoded with like something Q understands. So we have context that encodes P, which is the image, and that val is validated that way. And if for some reason the fields on that image uploads are not valid, if any of those fields is invalid, doesn't respect the schema, it's going to return an error. And then we can handle the error. So in this case, we make the post request that will call this function, and then we get the body of the request that we deserialize into the image upload, like image variable. And after that, we validate the image. And if it's invalid, then we handle it that way. We return a HTTP 400. Right. So see 400 bad request. Right? Does it make sense? No?
It does. Thank you.
Okay. So let's quickly look at the. Okay. So for those that didn't attend the last two sessions, I hope you have more context now.
Yes, just a quick question. So where do you place the JSON file as far as the demo app? So the Go file and the JSON file, they have to be in the same folder? Because I don't see any calls making to that JSON.
Yeah, so, okay. So if you pay attention here, I'm using the embeds out of the Go standard library. So embed.fs, fs stands for file system.
File system.
Right? So it's a file system, okay? So in the annotation, I put the star. So since I put a star, this contents virtual file system points to the contents of the demo5 directory, which contains the OpenAPI JSON. Okay.
Okay.
And if I scroll down, where is it? Let me search for this one. Where did it go? Okay, so here. So it's the same thing. It's the same content virtual file system, right? So since this one contains the OpenAPI JSON, I can just read the contents of the file into this variable, which is called spec. And then whenever we call the / OpenAPI.json, we just write it to the response. And it gives us this. Right? So the / OpenAPI.json is the same as this one.
Yeah, got it.
Right? Okay. So let's just go back here. Okay, so I mentioned some utilities that are created. So you can see some of them here. So I have the YAML to JSON, and you can go over the code. It's in that GitHub repo. So this is what's happening here. And I also have the extraction of images, extraction of information out of that image based on the prompt. And same thing for the streaming version. Okay, so I'll show you. I'll show you the image information extraction. So when I run the CLI, I mentioned that I want to extract the information out of this image which is on my disk. So that image, so I specified the path and then the prompt. The prompt that I attached to it is that the LLM, in this case GPT-4o, should describe the scenery out of that inside that image. So let's see it in action. Okay, so you can see that the response comes all at once in one block, and the image itself, let's see. it possible? Oh, okay. Where is this? Okay, I'll show you the image when I open the UI part. So notice how the response just comes in one block. And this is what we were doing in the last session, okay? And when we left in the last session, we were discussing how we can stream the response instead of receiving it all in one shot, in order to provide a better user experience. Because notice there's a small delay. We wait, and then boom, we just get the whole text block. Okay. You should compare this user experience to what we are used to when we use whether it's Anthropic or ChatGPT and so on and so on. You can see that they send the first few words out of the response like right away, and then we can see the rest of the response just streaming in, right? So let's look at the variation out of that information extraction. Okay. So you can see that now the response is streaming in like one word at a time. Okay. So let's see how this is implemented. So it's this command over here. So I'm using a small library called Cobra that helps me grab the details, the CLI, the values from the CLI, notably the path and the prompts. So first argument will be the path and then the prompts. And then this is the text that you saw, like extracting, and then the image path. Okay. So the first thing that's being done here is that once we read the bytes out of the file, just like I was describing earlier, we turn those bytes into base 64. Okay. And once we turn them into base 64, we are then able to serialize the whole payload. Serialize the details of that image together with the rest of the details in the payload, like for example the prompt, so that we can send the whole thing at once to ChatGPT 4.0 for processing. 4.0 is a multimodal, so it deals not only with text but also images. But in reality, the model doesn't really see an image like us humans do. It sees an image also as text, right? That's why it's important to encode it this way. Okay. And in the demo project, I already know that the image is a WebP image, right? So that's why it's hard-coded here. And the part that we specify that we want GPT 4.0 to process an image is that we have to have this key value pair. Okay. And then for the streaming version, we actually have to add this additional field, which is stream equals true. And then we construct the post request. And we check for we check that everything is okay when we make the post request. And then if everything is okay, since we enabled streaming, we have to we have to scan through the response body, because the responses will come chunk by chunk, right? So we instantiate the scanner for this, and then we go through it line by line, okay? And behind the scenes, the streaming for most of the LLM providers is usually leveraging server-sent events. So let's see, server-sent events. Let me share the link here. Okay, I don't have. I mean, you can read the details of how they work, but the main idea is that the main idea behind server-sent events is that the actual data coming back will be in that shape, like, and then some text over here. It's gonna have a similar shape, so it will have like data and then some value after this, right? If the server-sent event is consumed from the browser, you usually will have some additional metadata like an ID, some number, and then I think the event name. I don't know. LLM response, something like this, right? But in this case, since we do it like in a way like server to server, we don't actually need this part, right? And they don't actually send this part. So we just have something that looks like this: data, colon, and then the actual information. Okay, so since this is the actual information that comes back, we need to extract it. So that's what's being done here. We remove the prefix, which is data colon space, in order to end up with the actual data. And as a convention, when they are done streaming the response, they send this text over here to indicate that they are done responding. And then we should be able to close the collection. Okay. So if that's not the case, it means that we still have data, right? In that case, we can pass it, and then the location of the content is as follows. We're gonna have a choices array from which we grab the first element, and then the field called delta, and then another field called content. Okay, so that's the operation over here. And then here, I'm the one who added an arbitrary slip. This is not necessary, but for the purpose of the demo, I had to slow it down so we can see what's happening. So, any question on that? Okay, no questions. Okay, so let's go back to the demo 5. So this is exactly what I've done in the server that I showed you over here, which is the demo 5. By default, the responses come in one block like this with info, but we can enable the streaming and then have the streaming equivalent coming back. So in order to detect that, let me see. Process of measure. So in order to detect that, that stream field, which is part of the payload, after it has been passed, it becomes a Boolean over here. So if it's true, then we set the proper headers, the content type should be text event stream, and then keep alive so that the connection stays open. And then we can start writing the data. So writing the data is just like I showed you for the CLI example, but with a twist. Since we don't write to the console, but we write to the response, we have to do this dance over here. And you can see that in this case, I'm also using that format of the server sent event, which is data colon space, and then the actual values, right? And this is what's going to stream back to the client. Okay. And every time we write a chunk of the response, we need to flush it down to the client. So the client receives it and is able to proceed with the rest of the functionality. So from a high level, let me see, is that possible to expand this? Okay, so from a high level, this is what's happening. From the UI, we indicate that we want to stream, we want a streaming response. So we make this call from, I will show you the UI shortly. From the UI, we make a call to the backend, by uploading the image. The backend receives the base64 and then turns around and redirects that payloads to the LLM. And then in our case, ChatGPT will receive the image, process it, and then since we indicated that we want a streaming response, ChatGPT, in that case GPT-4o will, or OpenAI will start streaming the response back. Okay, and when we receive that streaming response from the LLM, like in the backend, we right away forward it to the UI, right? And then the UI is free to handle that stream however it wants it. So it can buffer it or it can display it right away. Okay. Any question on that?
Yes, it's a quick question. So for this to actually work complete out of the box, do you need to handle the sessions with ChatGPT? And also, where do the images are being uploaded to ChatGPT for processing? Do you actually save that on the back end also?
No, nothing is saved. So actually,
So how do you build up a multi-quote? So a quote, let's say I ask ChatGPT, how are you? And then it gives me a response, and then I want to build off of the previous prompt. How do you continue that session?
Oh, okay. I see what you're saying. So no, in that case, this is not. I mean, this implementation is not persisting the exchanges. There's no history. We can go back to the previous prompt and make edits or anything like that. In this case, everything is happening, if you want, real time. So when the client makes that call, it's not one call and then the connection gets shut down. When the client opens this connection that reaches the server will hold that connection from the client and then open a connection to ChatGPT or to GPT-4o, right? So both connections are open between UI and backend, and then second connection, backend to LLM, right? And using these two open connections, like the LLM, using that open connection with the backend, will start responding, streaming the responses back, right? And then the backend, since it has the the UI connection still open, it's just going to forward it to the UI. So nothing is saved. Everything happens real time.
Okay, thank you.
Yeah. Okay, so let's show you the UI real quick. Let's reload this. Okay. So my UI is buggy, so just so that you know, but I just want to show you quickly. Okay. So two things are happening here. Let me see. I'll go in the inspector. Okay. So we covered this one last time, but what did I do? Send the inspector. Let's look at the form. Okay, so here's the form. So the form not only has these two inputs together with the submit button, it also has, let me decrease it a little bit so I can show you. Okay, it also has a hidden field. And you can see that the hidden field contains the MIME type of the image, right? So if I reload, you'll see that the field containing the MIME type is empty. And as soon as I pick an image, like in this case, I picked the PNG file. As soon as I pick it, you can see that the hidden field containing the MIME type is populated, right? The way it happens is that using I'm not sure exactly how it happens. It's an implementation detail in the browser and the form. But what's for sure is that I have a hook in the code, in the React code, to basically derive the extension from the file which is about to be uploaded, right? So I don't manually inspect the file name and grab the extension. I just get a file object that I can inspect. Actually, let me show you that code real quick. So I'll go to demos, Frontends. I think it's this one. Okay. So this is the handler to handle the file selection. Okay, so when we pick an image over here, this part is handled by the handle file change, right? And then this one is basically a file object, and it has a field called type. And this is what I use to set the hidden fields. So however it happens, whether it's the browser and the browser maybe checks the file extension, I don't know, but this is how I do it. Okay. And then the second thing is that I can pick the description. And then we are ready for processing the image. So like I said, I have some, this part is a bit buggy in the rendering, but I can show you the, okay, so this is the server running. You can see that it's streaming the responses. Okay, so you can see, I don't know if you can see it on your screens, but this part here is flickering because every time a chunk of text comes to the UI, I have a hook to re-render the results part, but it's a bit buggy right now. So let's let it finish. Okay, so now it fully rendered like this. Any question on this?
Yeah, what happens if you choose a file that is not an image, that it's not a PNG or a JPEG?
Well, good question. Let's see. Let's pick something. Let's see. Oh, like it doesn't even let me. You see this? My file picker is like grays out all of the stuff that are not images.
Mm-hmm.
Right?
Click on show options. Try it again and click on show. So I mean, what if it was a corrupt image? Okay, so instead of image shot, let's make it all file.
All fine.
And then choose like a text file or
Okay, so let's pick.
anything, PDF. Yeah, that's fine.
My friend wrote the paper. Let's see what happens. The process photo, boom, it fails. So why did it fail?
Okay.
Okay, so here it says failed to process image. Let's see the browser. I mean the backend.
It's encoding, right?
Yeah, it's encoded. Okay.
I mean, it did not. It's not the right encoding. That's why I did not process it.
Not exactly. It says that it's out of bound, right? Because
Yeah,
it doesn't match this.
it doesn't match the criteria. Yeah, so it's doing what it's supposed to do. Excellent. Okay.
Right. Right. So it doesn't fail because it's not an image. It fails because whatever that thing is doesn't match these criteria. Right.
Which is, you first see the first part of the criteria. It says the data has to be an image. So that's actually failing because it's not an image, right?
Yeah, but in the codes, if I'll show you the code real quick. So in the codes, this part, which is data column image slash and then the image type and all that, I'm constructing by hand in the code. Let me see. So this is where I convert base 64. So buffer. Okay, so this is where I have the base 64 and upload. Okay, here it is. So I'm passing the data type. I mean the MIME type. So this one most likely will be wrong. Let's look at the UI. Let's see the error here. Oh, I should have logged it, but let's see what did it put. Okay, so you see this? When it was in print, it did data colon application slash PDF, right? And application PDF is not contained in these list of options here. Here it deals with JPEG, PNG, GIF, and WebP. There's no PDF. Right?
Okay. It's doing what it's supposed to do.
Yes. Yes. That's why it's failing. Right. Okay, so this one is the okay. Yeah, so that's what we were just looking at in the IDE. So having the file type derived from the image field. I mean, having the file and the file type both derived from the image field. We go ahead and and grab the contents of that file, just like we did in Go, right? We get the bytes out of that file and we turn them into base64. And then we construct the blob, which is data column, and then the image type, semicolon, base64, comma, and then the base64 encoded bytes. And then I construct the payload. So it has the prompt, it has the indication that this is that the response should be streamed back, and then we have the blob, and then we make an API call to the server, right? And so after we make this call, we have the response. We check that everything is okay, and then if everything is okay, then we know we are expecting a streaming response, right? So it means that we have to read the response as it comes. So for that reason, instead of just reading the whole body at once, just like in the synchronous version, we get a reader, okay? And then from that reader, we derive a readable stream, okay? And this is the how we want to turn the reader from the server. Okay, so let's go back to the diagram. So we make this call, and out of that call we get a response, right? But this is the handle. This part here, that reader handles the part between the backend and the UI. I mean, when I say the UI, just to be clear, the UI that I'm showing you here has two parts. It has the visible part in the browser so that us, the clients or customers, can interact with it. But that same UI has a server component. Okay, so this reader here handles the connection between the server components of the UI and the backend. So it's that part over here, number 4. Okay. And then in order for us to see the response, actually, let's look at let me clear this one. Let's just do it again. Let me pick another image. Okay, so this time if I make a call, set timing. Okay, so we can see the response is streaming in. There's no good way to visualize it, but timings. But we can see that it's streaming in. You can see the timer on the right. Okay, so this part between the browser and the UI backend is handled by this readable stream. Okay, so when we call the Go backend, we have this reader that handles the connection with the Go backend. And then this readable stream handles the connection between the server side of the UI and what's happening in the browser. And this operation here connects the two. So the stream coming from Go is connected to the stream that goes out to the client. Does it make sense?
Yeah. So the stream is not really streaming, right? So if you're streaming between the server for the browser and the UI, you're actually getting the response still as one chunk, and you're just visibly streaming it to whoever's looking at it. So you're not really getting a stream from the ChatGPT, and you pass it along the server to the UI, and so it's not like when you ask the question, it starts streaming the answer. When you ask the question, it processes, it understands what you want, it gives you the answer, and then it gives it back to you in one chunk. But your server,
No, it doesn't do that. So again, if I go back to the, let's see, is that demo file? Let's see, we still have scanner. Okay, so after we make the call to ChatGPT, right? We create a scanner out of the body. So the scanner is used specifically for streaming responses, meaning that we do not have the full body, right? This thing here is basically maintaining a connection with ChatGPT or with GPT-4, right? And then we in the for loop, we check for any new chunk available coming from GPT-4, right? And if we have any chunk available, then what we do is that we extract it from the events coming from GPT-4, and then we flush it to the client. The client in this case is our Go backend. Sorry, the client in this case is our UI server side. You know, so as we get it, we flush each chunk to the UI backend, you know, through this reader. And this reader itself is connected to the stream, which represents the connection between the browser and the server side of the UI. Right, so everything flows. There's no, like, we don't buffer anywhere the full response from ChatGPT and then send it to the Go backend that will get the whole thing and then send it to the UI. No, we do it as it happens. Any question on that or clarifications you want to make?
oh, thank you. I'm good.
I don't know if you touched on that or not, but are there any, excuse me, are there any sort of like performance issues, whether you do it via streaming versus, you know, just kind of like dumping it all at once? I know, you know, it's nice to see streaming happening, but, you know, are there any sort of like performance differences or anything you've noticed, you know, whether you do it like streaming versus kind of doing it as like kind of sort of like a batch mode?
Well, I mean, in this case, like you saw earlier when I was showing the restrictions for the image, and I made that calculation so that the image is up to 10 megabytes, like this. Oh, where is it? Yeah, this image uploads. No, stream. Okay, here it is, the blob, like this one. Okay, so this is technically a string, right? But in memory, it occupies a 10 megabyte space. So if you keep this idea in mind, when you have a chunk of text, that chunk of text will also occupy space in memory. Okay, so imagine, let's assume that when we prompt ChatGPT or when we prompt the LLM, we get like a 1 megabyte response. You know, text which is equivalent to 1 megabyte in memory. Okay, and tomorrow, with your 2 gigabyte of RAM server, your app somehow becomes very popular. Okay, and you have like hundreds and hundreds of people who are prompting the LLM through your app. If you keep all of the text in memory for all of your customers, you know, when they make all those parallel calls to your app, your server is going to crash because there's not enough space to accommodate everyone, right? So instead of buffering in memory and occupy your RAM, basically you grab a piece and then you send it through right away. That way you don't occupy space.
I see. Okay. So yeah. So I guess I can think of it as like having like a bucket of water and getting water from the faucet. Instead of letting it fill up, it's better to have an exit right away to like serve it to the other side while you're getting water from the faucet, for example. Yeah, I think
exactly. When your sink is backed up, what happens?
Overflows.
It overflows, right? It's the same thing. When your sink is backed up, it means you are buffering the amount of water you might want to consume, maybe. Right? Or let's say, like, take another example with liquids. Let's say you're very thirsty and you want to drink 1 liter of water. You cannot just swallow 1 liter, right?
Yeah, it'll take. Yeah.
Your glass, you drink, you fill up your glass. It means technically you can swallow 1 liter, but not at once.
Yeah.
Just a chunk at the time.
Right. Okay.
So
okay, that makes sense.
Right. There's actually I forgot the name of that book. I think the title is Systems Thinking or something. I forgot the exact title. Let me see. Systems Thinking. I think it's this one. Let me check. I think it's this one over here. But it's not a computer science book. It's the book discusses like systems in general, right? And when you read this book, you will run into that concept a lot. You know, because when people want to make account for the logistics of different things for systems that they manage, they have to be aware of how the resources flow. You know, that way they can make predictions like, okay, we need to fill up by this date so that there's no disruption of the service at that date, like things like that. You know, so you're thinking about flows and where it makes sense to buffer, where it makes sense to not buffer and you know, like keep things moving. You know, it's the same idea. So with limited RAM space in your server, you know, like the same 2 gigabytes can accommodate way more customers if you flow the information. You know, everybody can, let's say you have 200 people prompting all at once. At most, you will have 200 words in RAM. Even though the final answers for each one of them might be like 1,000 words responses. Yes, go ahead, David, with your question.
Yeah, I also wanted to add to that, and pretty much a counter to it, right? It also depends on other factors, because when you're streaming, you also have to think about bandwidth. So there is a trade-off there, right? You might be saving in memory, but you might be paying more in bandwidth. So because of that, there could also be a way where you can actually retrieve the data, store it, and then now bundle it and then send it. And sometimes you need to stream it because it's a huge file. Let's say at 1 gig, right?
Right.
You have to stream it. But when it comes to client and server connection, bandwidth also is something to consider, because you're not just getting the data and showing it to the user, right? You're getting it and you're sending it to the client now. And then now that's also money that you're going to be spending. So you need to consider all these.
Yeah, but I mean, whether you stream or you send the response all at once, it's still going to consume the same bandwidth. You know, if we take the case of a single user, if the full response that they expect is 1 meg, you can send 10 kilobytes at the time by streaming and still end up with 1 meg bandwidth use. Or you can just send the whole 1 meg, and it's still.
Yeah, it's a bit different, because when you have a connection that is held for that long, and then let's say you make 1,000 API calls, right? Versus 1 API call and you receive the response, it adds up. You know what I mean?
Yeah, but when the connection is open, like most providers, cloud providers, don't charge for connections. They charge for egress. Egress meaning that data has to be flowing from your server to your customers. If there's no data flow, then nothing happens. You know, but then.
Let me ask you this question.
Hold on, let me finish up. But then if you are worried about the number of connections, this really depends on the type of backend you have. Some backends can handle a very large number of connections. Even if they don't send data right away, they can manage it, having a bunch of connections open. Some other server implementations do not. You know. So yeah, that's what I wanted to mention. Go ahead.
Okay. No, that's fine.
Mm-hmm. Yeah. Yeah. So what did I want to say? Yeah, and also to come back to what I was just saying, the implementation details of your server also matter. Most likely, if you have I don't know, if you have a backend that cannot handle many threads, like let's say there's no event loop to handle the connections or anything, and it's using threads, your server will quickly crash if you have too many connections. Or if it's not crashing, like the request will fail right away. But if you have something that has an event loop like Node.js, for example, Node.js can most likely park a lot of open connections to the side until there's data to send back to the client, But if you really want to go big, maybe you use something like Golang or Erlang or something like that. That can handle maybe an order of magnitude more open connections. So yeah. But for bandwidth, it doesn't matter if you're streaming or sending the whole thing. You're still gonna end up consuming the same amount of bandwidth. But if you send everything all at once, you might be able to serve only a few clients, depending on on what's available on your RAM. And then if you have limited bandwidth, that will also limit the number of clients you can serve. Because let's say you have a 10 megabytes bandwidth. It means that at most you can serve 10 clients at the same time, meaning sending them data at the same time. And all the others will have to wait. So yeah, but like I was saying, maybe if you are interested and you read that book, it's not a computer science book, but it's gonna give you some good ideas about those things. And then when you are implementing your systems, you can take all of that into account. Like for example, where it makes sense to buffer data, where it makes sense to stream. Like if you are handling multiple streams, it will also help you think about where some streams are maybe lagging. And because let's take this example into account. This is a use case that happens a lot. Like when you build real systems, right? Let's say you have some data source which is streaming, okay? Or maybe it's a queue something that produces a whole lot of data, a kind of like similar to the Twitter firewalls like back in the days, right? The system in the middle has to consume it like as fast as possible, right? If the part that produces the data is faster than the part that consumes it, this guy, even if you don't want to, will start to buffer the incoming data and at some point crash. So you have to make some tweaks so that it can catch up. Or if it's not possible, you have to find a way for this guy to tell the producer to slow down a little bit so that it can keep up. So this is just one example of what's actually happening when you deal with multiple data providers and consumers and stuff like that. So, yeah, in most of the use cases for the LLM consuming the responses, the data producer, which is the LLM, is usually the slowest. So yeah. So just to summarize, the streaming is makes sense for for AI-enabled apps, because since the data provider is very slow, you don't want to keep the client waiting. So as soon as there is a piece of data that is available, it's better to make it available to the end user. And then an added benefit to that is that it helps you manage your server resources. You don't have to have that big of of a RAM for your server, right? So that's about it. There are some other use cases that I wanted to cover, but I'll probably do it another time. But yeah,
this was a great overview of like API development from part 1 to 3. So yeah, that was awesome.
Yeah, and I promise this time I'll finish editing those videos at this point.
Because we still have video 1 and 2 that's still out there, right? We need to.
So sorry guys, I've been so lazy the last couple of weeks. I'm so tired. Yeah. So you'll be able to watch the part 1, part 2, where I go into a lot of details about what we quickly covered at the beginning. So yeah.
Yeah, thank you. I think part 3, this part actually is where I should start and then go back to the other ones.
Yeah. Yeah, but 2 things to remember. Server sent events. That's the name of the game when you talk about AI apps. They all do that. It doesn't matter which one you use. You know, it doesn't matter if you're using V0, like Entropy, ChatGPT, like whichever one, they all stream back and forth. So yep.
Well, thank you, Ben.